Welcome to Engineering Scales Models. I'm Jason, your host, and I do models. How is everyone doing today? We are continuing our CMOS logic series with the chip CD4011. So let's take a look at what we got here. This is a CMOS NAND gate. So it is a CMOS NAND gate, and it is a two input, so it looks like this with a little inverter on it. So you have A, B, and then you have your output. So if you have a truth table, you have A, B, and your outputs, you have 0, 0, 1, 1, 0, 1, 1. So that's all your possible combinations. So because this is an AND gate, both inputs have to match in order for it to put an output. So if it's an input of 0, 0, the output's going to be the inverse of that, so it's going to be a 1. If it's a 0, 1, it doesn't matter, they don't match, so it's going to be a 1, it's going to be the opposite. So if you have 0, a 1, 0, it's going to be it's going to be a 0, it's going to be nothing, so it's going to be the opposite of that, which is a 1. But if you have a high, a 1, 1, it is going to be the inverse of that, which is a 0. So this is a NAND gate. Now let's take a look at the data sheet here. Here is the data sheet. They come in 3 different chips, the 12 and the 23. Let's see, they are a 14-pin dip package. They run between 5 volts and 15 volts, supposedly. I wouldn't want to run it. They technically say up to 20 volts, but I wouldn't want to run it at that. I run my chips at 5 volts. But they have a quad input is the 12, a dual quad input, and then they have a tri 3 inputs, so you have 3 chips with 3 inputs each. And as I said, it gives you the inverse of all of the units. So let's take a look. I drew this up for a pin output here, so, and then let me move this over here. So, see if I can make this a little bit better. So here we have our chip. It is our CMOS it's 4011. I have the number wrong up top there, but that's pretty easy to edit in this here. There we go, 4011, and then here it is. You have pin 1 and pin 2 are your inputs for the pin 3 output. Then you have pin 5 and 6 are your 2 inputs for your pin 4 output. And then you have pin 8 and 9 is your 10 output, and pin 12 and 13 are your 11 output. And then you have pin 14 is your plus 5 volts or your VCC, and then you have your pin 7 is your VSS or your ground input. So let's take a look at what this chip looks like here, and I'll show it to you in a circuit. So let's switch to the overhead camera, and we'll see if I can show you this. Here is the dip package, and there it is, 4011. This is a BE version. I do not know what the BE stands for, so we will put it in our circuit here like so. So we have our two outputs, and we will hook this up to power and ground, and you can't see that. There we go. We have our two inputs. They are tied with pull down resistors to 5 volts and ground, and we will put our power on there and our ground on pin 7, and then we will take our two inputs. So we will take our first input and we will put it on pin 1, and our second input, and we will put it on pin 2, and then we will take a look at the output on pin 3. Output on pin 3, so we got a little LED there. So if I turn this on with the 5 volt power supply, all theory, the light should have came on. Okay. Okay, for some reason I'm not getting anything here. Input 1 and 2, and output is pin 3. Backwards. So let's just check to see if we have voltage on the, and I'll put my meter up. This is troubleshooting here, and I'll put amperage shot. Alright. I want to measure the amperage coming out of that circuit going through an LED. So got leads everywhere, so I'm going to come out of that pin, and then I want to come into this LED. And I'm not measuring amperage. Okay, let's try this now. Okay, so 4 milliamps, so technically you don't need a resistor coming through this LED from one of these CMOS chips. So in all theory, I could take this and I could plug it in just like that, and then I can control that. So it was 4 milliamps, which is way under the 20 milliamps of a LED. I don't know if I would run it like that forever, but that's the amperage that the chip runs at. They tend to run at a lower amperage than your TTL chips, which would be the 74LS series that we'll be looking at later. But back to this circuit, if one's pressed, nothing happens. If the other's pressed, nothing happens. And if both are pressed, it turns off. If both are on, it is on. And that comes back to our truth table over here. If you look at our truth table, if they're both off, it's on. If B, nothing, it's still on. If A, it's still on. And then if both are pressed, it's off. Now here is an interesting thing that we can do. We can take a, let me get this zoomed in here. And let me go directly back to this, and I'll show you a cool trick. Okay, let me clear this. Okay, let me show you this. So I have a NAND gate like this, and I have my output, and this is A, and this is B. So whatever this is, it's going to be A and B, and it's going to be the opposite of it. Well, if I take a NAND gate like so, and I tie A and B together, and I have an output, I will have a truth table like this. If it's a 0, it's a 1. If it's a 1, it's a 0. So 2 NAND gates will make me an inverter. So if I take this signal, this output signal from here, and plug it into 2 NAND gates, I will have an AND gate. AND gate. And this is where combining logic in an AND gate truth table, an AND gate looks like this. This is an AND gate, A, B, and out, and an AND gate looks like A, B, output 0, 0, 1, 1, 0, 1, 1, and if both are 0, it's 0, 0, 0, 1. So it's pretty much the opposite of a NAND gate. Now, you wonder why not just put a CMOS NAND gate down. Well, you can't do that because CMOS chips use a a complementary metal oxide silicants. That's what CMOS stands for, and it's a little bit difficult. You can't really make an AND gate, but that's what the beauty of combinational logic is. So if I come and pull my LED out, I'm going to turn my power off, and I take, let's just take, for example, we will, so pin 3 is my output. Take pin 3 and I will put that into pin 5 and 6. Pin 5 and 6 of my gate here. Then I'll come back and I'll plug my LED into pin 4, which is my output of the second AND gate. Now if I turn this on, second NAND gate, I'm sorry. If I turn this on, well, you see the LED's off. If I press that, I press them both, it comes on. So I used 2 of these NAND gates to make an AND gate. So, and you know, these are old chips. These are chips from the 70s, 80s, and 90s. So having only 4 gates on a chip, that's not a lot. So, you know, modern day chips can pack a whole bunch of logic circuits on there, and you can get combinational logic that uses the NAND gates to give you an AND gate, and you'll have AND gates on a chip. But this is, if you have simple circuits and you need an AND gate, you can use 2 NAND gates. So, and there's other ways to combine them into different operations. But this is going to do it for this chip. It was the CD4011 CMOS quad input NAND gate. That's the pinout. I drew this up in iCircuit. It was, you know, the best I could do, and now it's a reference, and I might put the link for the file in the description of the video. But that's going to do it for this video. You can check